Okay, so today for our lesson we're going to talk about real numbers and the number line. So our objective is to classify, graph, and compare real numbers, and to find and estimate square roots. So a quick key concept here is the concept of a square root. Square root of a number, a, is a square root of b if a squared equals b. So we talked a little bit about squaring numbers before. A square root undoes the act of squaring a number. So an example, if 7 squared is 49, that means that 7 is a square root of 49. And this essential understanding just kind of talks about that a little bit further. So I'm going to read this for you. You can use the definition above that I just talked about to find the exact square roots of some non-negative numbers. You can approximate the square roots of other non-negative numbers. That radical symbol, this right here, indicates a non-negative square root, also called a principal square root. The expression under it is called the radicand. Now, radical, radicand, those vocabulary terms, of those two, the one I'm going to use the most is radical, and the radical is that square root symbol for us right now. So together, the radical symbol and the radicand form a radical, that whole expression. So negative square roots, we're not going to deal with those right now. We're just going to deal with positive square roots, non-negative square roots. So it's just being able to evaluate these. So in this first problem, I want to know the simplified form of each expression, each radical. So I look at the square root of 81. And there's different ways you can think about this, but the way I think about evaluating the square root is I think to myself, what times itself gives me 81? I would say 9. 9 times 9 is 81. If you use a calculator, that's fine. If you want to use a sort of table, I can provide you with one, but the perfect squares are kind of a nice thing to know, especially going forward in this class, so just keep that in mind. Part B, it's a little tricky because it's a fraction, but you can think of this one also in a few different ways. I'm going to think of it as, this can just be the square root of 9 divided by the square root of 16, if we want to kind of simplify it that way. And I think of the square root of 9. What times itself gives me 9? That number is 3. For the bottom of that fraction, what times itself gives me 16? That number is going to be 4. So 3/4 is our simplified form of that expression. Now moving on to the got it. I'm going to ask that you guys pause it, wait a few seconds, and I'll show you the solutions and explain through those for a second. Okay, so here are my solutions. And for A and B, it's just basic knowing your times tables essentially and knowing what some of these perfect squares are. So we'll get more comfortable with those as the year goes on. If you used a calculator, that's okay, but square root of 64 is 8, square root of 25 is 5. For the fractions, I just think of it as I take the square root of the top and the square root of the bottom to evaluate that. So for 1 over 36, the square root of 1 is just 1. 1 times 1 is 1. Square root of 36 is 6. 6 times 6 is 36. Part D, square root of 81 over 121. Square root of 81 is 9. Square root of 121 is 11. So moving on. The square of an integer is called a perfect square. 49 is a perfect square because 7 squared is 49. When we find a number, a radicand, something that we're taking the square root of, that is not a perfect square, we can estimate, okay? Now you're going to use calculators for a lot of these, but I like you being able to estimate some of these because then you kind of understand what is kind of a range of correct answers or if that your answer was close to being correct. So, the value of square root of 34 to the nearest integer. So when I look at that square root of 34, I've got to think of my perfect squares, all right? So there's two perfect squares that 34 falls in between. 34 falls between 25, the square root of 25, and the square root of 36, which means the result of this square root falls between 5 and 6. Maybe I shouldn't use a plus sign there. I'll say 5 and 6. Okay? And then we think, which number is square root of 34 closer to? Well, it's closer to the square root of 36. So the result is closer to 6. And the way you can test that is you can take the square root of 34, and I'm just going to verify that in my calculator. It's about 5.8. So that should make sense that it's closest to 6. So we're talking about what's the nearest whole number it's close to. Nearest positive whole number, it's going to be 6 for that one. So again, for the got it, try it. Pause the video when you try it, and I'll show you my solution and kind of explain why I got that solution. So for this problem, you see I just decided 76, the square root of 76, has to be between the square root of 64, the square root of 81. And I can tell that the square root of 81, we looked at that before, it is 9. So square root of 76 is closest to 9 as an integer. And again, if you want to verify that on a calculator, that square root is about 8.7. So it checks out. So what I'll have you guys do is move on to the next step in the lesson. Make sure that you're doing all the must-dos, and I'll have you come back to these notes for the next video.